Okay, Houston, we've had a problem here.
This is Houston. Say again, please.
Houston, we've had a problem.
Houston, we don't have a problem. Today we're going to learn about something called a limiting reactant. Now, the best way to understand a limiting reactant is to watch this short video clip. So here I am in my garage with one thing I love to do, and that's ride bikes. Now, what I've got here is I've got 3 of my sort of bikey things. And if you know, there's really a formula. The formula is this: 2 wheels plus 1 frame makes 1 bicycle. So here's the problem. How many bikes can I make with these frames and these wheels? Well, let's count them. Frames, 1, 2, 3. 3. That's good, 3. Wheels. Now, I got some wheels here, don't I? I've got 1, 2, 3, 4, 5, 6, 7. I've got 7 wheels and 3 frames. How many bikes can I make? So as you can see, I made 3 bikes, but I have 1 wheel left over. So the wheels were the excess reagent, and the frames were the limiting reagent. So we've already learned about stoichiometry, right? We've got recipes. So in that case, with the recipe, which was what? We had F plus 2W turned into 1 bike, right? And in that case, we had 3 frames and we had 7 wheels, but we were only able to make 3 bikes. And we had 1 of these left over. You see, we've been doing math where if we know like a given amount, we can figure out how many bikes you can make. That's the recipe. But what happens if you have multiple amounts of reactants? That's how we do stoichiometry. Let's first start by defining some terms. So we've got 2 kinds of things. We've got what we call the limiting reactant, and we've got the excess reactant. Now the limiting one, it sort of makes sense. That's the substance that you're going to run out of. So in my case, it was the wheels, right? And then the excess is one that you have more than enough, right? So keep that in mind as we're trying to figure out like how many bikes we can make, or there's actually a variety of different questions that we could answer when we do these types of questions. So let's take, for the example, a chemical reaction. Let's take a double replacement reaction. Let's say I've got FeCl3 reacting with sodium phosphate, which would be Na3PO4. It reacts and it's going to make FePO4 plus NaCl. By the way, I've played the charge game to figure out what that is. Iron is +3 and phosphate is -3. To balance this equation, you have to start with a 3 here. And that's it. So it's 1, 1, 1, 3. So that's our balanced equation. Like any stoichiometry, you can start with a good balanced equation. But now let's say that I have, 15 grams of iron chloride. We start with what you know. But I also have 23 grams of sodium phosphate. Now the question that's often asked is how much of some substance will we form? By the way, if I looked at my solubility table, this is solid and this is AQ. And usually the one we're most interested in is the solid. Now, when you're solving this problem, how much you're going to make, one of these is limiting and one of these is an excess. And the way to do this is we're going to simply do 2 stoichiometric lines to solve the problem. Right? So I've got my calculator right here. So FeCl3, I'll start with 15.0 grams of FeCl3 over 1. Now remember what I'm going to be doing, right? I'm going to be using the stoichiometry table, right? I'm going to go from grams to moles, moles to moles, and moles to grams, right? And I'm going to do that, and I'm going to say grams of FeCl3 to 1 mole of FeCl3. Now, I get this number from the periodic table. I'm going to do this quickly on my calculator. Iron weighs 56 plus 35.5 times 3. That comes out to 162.5. That's from the periodic table, right? Now, remember from stoichiometry, we learned this how to do this. We're going to do the mole-to-mole ratio. Now, actually, back up. The grams of FeCl3 cancel, right? And now I want to get rid of moles of FeCl3. Now do moles of FeCl3, and that's going to go to moles of FePO4. Now the ratio here is 1 to 1. All right. Now, careful. The example I've chosen, this is a 1 to 1 ratio. This could be 3 to 1 or 5 to 1 or something like that. And then the moles of FeCl3 cancel. And then I'm going to convert to the grams of FePO4. So I'll say 1 mole of FePO4 is so many grams of FePO4. Now I need to find the molar mass of FePO4. Calculator man right here. I'm going to say 56 is iron, plus 31 is phosphorus, plus 16 times 4 for the oxygen. That's 151 grams. All right. And now I'm just going to take the numbers on top, or I'll do the math here. I have 15 divided by 162.5 times 1 divided by 1 times 151 gives me 13.9 grams of FePO4. Now that's not necessarily the right answer. Watch this up here. Let's do the second one. Now, so what I've done, right, I converted grams of this to grams of this. Now what I'm going to do is I'm going to convert grams of sodium phosphate to grams of FePO4 and then see what my resultant answer is. And then we'll compare, you'll see. So if I'm going to say, well, boom, 23, so 23.0 grams of Na3PO4, right? Make sure I'm labeling everything. Then I'm going to say grams of Na3PO4 in 1 mole of Na3PO4. And this is going to be from the periodic table. Sodium weighs 23. 23 times 3 plus 31 plus 16 times 4 gives me 164 grams. Now what I'm going to do, it's kind of not working right, is I'm going to say 1 mole of Na3PO4. Now, by the way, when I say it's 1 mole, it's because right here, this 1 is a 1, right? And then I'm converting to this, and this is a 1 mole of FePO4. Again, this is the mole-to-mole ratio, right? And if these are 1s and 1s, this whatever these are, it's going to change. So this easily could be in another problem, a 2 and a 3 or something like that. And then I want to convert to grams of FePO4. The good news is I know that number. 1 mole of FePO4 is 151 grams of FePO4. Moles cancel. These cancel. Everything cancels except for the grams of FePO4. Now I'm going to take this number, 23, right? 23 divided by 164 times 151 gives me 21.2 grams of FePO4. Now let's think about this for a moment. How much are you going to really make? That's the question we're trying to ask. How many grams will you make? Go back to the bicycle analogy, right? I can only make as many as my bicycle wheels will allow, right? So ultimately, the one I can actually make is this, right? Because if I had done the bicycle wheels, thinking back to that metaphor, I could have made 3.5 bikes with the wheels, and I could make 3 bikes with the frames, so I could only make 3 bikes. So basically the lower answer is the answer. So how much can I actually make is I can only make the smaller amount. I mean, think about this as like a recipe. If I've got, 500 cups of flour, right, in cookies or something like that, and I've got 2 cups of sugar, the 2 cups of sugar are going to limit how many cookies I can make. And so in this case, this is like the 2 cups of sugar. So the FeCl3 would be labeled the limiting reactant. Why? Because we're going to run out of this first. And then the sodium phosphate is the ER, or the excess reactant. Now there's still one question that's often asked, and we're going to go there. Oftentimes the question is, how much of the excess reactant is left over? You see, for that case, I've got, so let's jot that question. So another question you're going to ask is, how much excess remains. And guess what you get to do? Another stoichiometric line. So let's do one more. Now watch how I do this. I'm going to take the limiting reactant. This is the limiting reactant. This is the excess reactant. I'm going to convert this to this and then subtract. So I'm going to start again. 15 grams of FeCl3. Good news, I know all these numbers already. And I'm going to go 162.5 grams FeCl3 in 1 mole of FeCl3. Grams cancel. Now I'm going to say, now this is the mole ratio right here, right? We're at the mole to mole. 1 mole FeCl3, but watch this, is equal to, 1 mole of Na3PO4, right? Because I'm converting from here to here. Now again, this example has all the ones except for right here, which kind of messes this up a little bit. It'd be nice if it was a different ratio. And then I'm going to go to sodium phosphate. I'll say 1 mole of Na3PO4 is equal to so many grams of Na3PO4, which was 164. Now I get my calculator and I say 15 divided by 162.5 times 164 gives me 15.1 of Na3PO4. Now what I'm calculating, if you're not quite figured this out, is I'm calculating how much of the sodium phosphate will be used up when you react 13.9 grams. And it turns out you're going to use 15.1. But look how much I had. I had 21.2. I used up, right? This is used up. That's how much I had. So how much is left over? You would take 21.2 minus 15.1. Well, that's just 6.1. So it'd be 6.1 grams of Na3PO4 left over. One thing that's sort of unfortunate about these problems is that each problem takes at least 2 stoichiometric lines. You do number 1 and you do number 2. You solve the problem, right? And then you pick the lower answer. And then if I ask for the excess reactant, you do a 3rd stoichiometric line, always going from the limiting to the excess reactant, and then you subtract. That's how you do limiting reactant problems. Houston, we don't have a problem. We'll see you in class.